Okay, let's continue doing the practice test here. We'll do problems 10 through 14. Okay, so what we're supposed to do is find the exact value of the expression. And the way to do that is we're asked to use a unit circle and not just punch it on a calculator. And so I'm going to go ahead and do that. So what I need to do is, these are in radians, and I'm going to look at the unit circle, and I have 0 where I've drawn it, and then comes pi over 2, then pi, 3/2 pi, and 2 pi. Okay, and I find the coordinates of those points. It's a unit circle, so where pi over 2 sits, I can see that the x-coordinate is 0 and the y-coordinate is 1. Well, that y-coordinate is sine, because always sine is the y-coordinate. How about at pi over pi? What do we have? Cosine pi. Well, pi, the x-coordinate is -1 because we're going to the left by 1 from the y-axis, and then 0 is the x-coordinate, and cosine is always the x-coordinate on the unit circle. Always the x-coordinate on the unit circle. And then let's see, where else do we have? 3/2 pi. Well, 3/2 pi corresponds to 0, -1, because it's down by 1, and to the right or left it's just 0. So again, sine is the y coordinate, and so that's -1. Okay, now let's go on to each below. Sketch a unit circle and draw and label. Misspelled label, annoying. Label the angle, then find the reference angle and label the reference in your picture. Then circle the value of the reference angle. Oh my gosh, okay, that's spelled right. Okay, I thought it was misspelled that. Okay, then circle the value of the reference angle. Okay, I guess all we're doing here is finding reference angles, nothing more than that. Okay, that sounds good. So, okay, here we have this going along, and all right, 225 degrees. How can we look at 225 degrees? Well, by the way, is this too small? Maybe. Why don't I make it twice as big? Okay, okay, so look, on the circle, here's 0 degrees, which is, I should put it not there, but over here. Okay, here's x and here's y, and y is 90 degrees, and then, at the top is 90 degrees, and I have 180 degrees as indicated, and here's 270. All right. Where's 225? Well, it's between 180 and 270. We're supposed to refer, when we're talking about the reference angle, we're supposed to refer to the x-axis, not the y-axis. I subtract that, and I get 45 degrees. I'll just sketch a 45-degree angle there. So that makes 180 plus 45 is 225 degrees. What am I doing? Circle the value of the reference angle. I think I can do that now. All right, I'll use a bright color. Here's the reference angle. That's the reference angle. It's the 45 degrees. It's an angle that that's made with the x-axis. Okay, now let's copy this over here and see if I can recreate that magic. That's a joke. All right, so I'll just erase some of that stuff that I have here. Now for this, we want to deal with radians. So I start with 0 at the top, and at the far right, and then I have pi over 2 and pi. Okay, actually I sort of don't even want to look at that pi over 2 that much. I'm referring to the x-axis. That's our method when we use reference angles. So pi is 6/6. Well, the difference between 5/6 and 6/6, maybe I'll write over here, but do I need to? 5/6 plus pi over 6 makes 6, which is pi. So I have this guy here, which I'm showing is 5, 6 pi. And the reference angle, again, is the angle that we make with the x-axis. And that angle is, as we see, pi over 6. And the way we see that is, you have 6, 6 minus 5, 6. Maybe I'll write that also. 6, 6 pi minus 5, 6 pi gives pi over 6, and that's the reference angle. Actually, to find the reference angle in general without drawing a picture, if you're doing radians and you're doing one of these special angles, you just look at the denominator as 6, and you get the reference angle as pi over 6. But I'm trying to follow directions drawing the picture. See? So we have 5, 6, the reference angle is pi over 6. That's enough, actually, to get that. Okay, so I zoomed out so you can see everything, and I'm going to stop this and upload.